Welcome to a tutorial video in C++. In this video, I'm going to talk about pointers. C++ is a systems level programming language. What this means is it has access to the memory of the program. You can use it to create new things using the actual memory of the computer to do things. This may sound a little crazy, but because of this, it allows C++ to do really complex things, because it can mold memory and create new structures based on that memory. All of this functionality, though, is based on this idea of pointers. The metaphor usually used with pointers is something like the address on an envelope. That is, if I was to mail something to someone, I would care about the contents, the value of a variable. I would also care about where it is, its address on the outside. So the address on the outside is the pointer. It points at the address, not at the value. It points at the location, that is. Let's look at an example of that. Down here on lines 9 through 12, we see we're creating an integer, defining it here. Notice it has a data type. C++ is a strongly typed programming language. It has a name. Variable names in C++ are letters and numbers, the underscore, but no spaces or special characters. And we see it has a value 5. Now we're using something new here, the ampersand next to the variable. In a previous video when we talked about conditional statements, we used two ampersands to be the AND, the Boolean operator. In this case, similar to the negation, the exclamation point operator, we're using the ampersand next to a value to get its location. I'm going to go ahead and click play so we can see that in action. And I'll move this over a little bit. We'll click this again. So the address of the variable is, and it gives us this address. This address is where it is in memory. That is, if we were looking all of the memory, we could go and find this location, this address. And this is where the value sits at. It's not the value itself, but where that value can be found. So again, thinking of pointers then, a pointer can point at a location, point at an address. It's not the actual value, but where the value can be found. I'm going to clear this and move this back while we talk through this code. So we saw the ampersand next to a variable gives us an address. So I mentioned pointers. Pointers are defined using the asterisk in front of the name of a variable. And this tells us that we are now not looking at the value of this variable, but something that stores the location of this type of data. So this full thing on line 15 is we're looking at an integer, this value right here, and its location, the location of whatever value this will be given. Notice down here I've sent that to its address. So the address of this value is now equal to a pointer, with the asterisk is in front of this, of an integer. And in fact, we see that on line 18. So I'll move this over and we'll run this again to verify this. So the result of line 12 should be the same result of line 18. And we see it is. The address of the variable is, and these are exactly the same. So over here on line 12, you use the ampersand in front of it to get its address. But down here on line 18 is we stored it using a pointer. So a pointer is something that stores the address, not the value, but where that value is at. Now, why are these two things important? Now, I started this video talking about system-level programming languages and dealing with memory. We can create new data structures using C++ and then use pointers to navigate through the memory and point at different locations to then get that data. So we can point at that data using a pointer and then get the data using a variable. Let's look through some examples of that idea. So a struct in C++ is a way of creating a new structure, a way of creating a new data block. It allows us to define new data types within C++. In previous videos, especially in the variable video, we talked about the different data types. We can have integers, floating point numbers. When we talked about conditional statements, I introduced Boolean values. Using the struct keyword, we can create new types, new structures of data, new data types within C++. So we see that right here on lines 23 through 27. The struct keyword the name of this data, and then opening and closing curly brackets. If you haven't picked up already, C++ really loves opening and closing curly brackets. It's defined using conditional statements, using loops, and again, you hear defining the structure of a struct. So we have a name node, and then we have the data that's within this. Now these don't have initial values. This is just the definition of this struct. That is the blueprint for this structure. We're not putting anything in it yet. We're just saying this is how this structure should look. It should have an integer named data, and we're doing something even cooler here. We're saying it can have a struct, it can have something called struct with a name node using a pointer. That is, it can have data within it that points to another struct of the type node. So we can have one node, one data with the type node, and then we can create a new node, and it can point to this next node. So let's look at that. Line 30 shows us we're creating a variable demo of the type node. I mentioned that structs allow us to create new data types. So as far as C++ knows, node is now a new data type that's defined lines 23 to 27. That defines its blueprint for this structure. This is our blueprint. It has integer data. It has struct node pointer next data as well. Two different data. There's no values yet, just the blueprint for the structure. So we're defining a new variable demo of type node. This is line 30. Line 32, we're saying, okay, for data, or demo.data is equal to 5. So say, okay, for the data that's inside node, set it to 5. We're using the dot notation. So we're saying, okay, data is part of node. So for the data part of node, set it to 5. So this allows us to expand data structures using structs. So we create a blueprint, and then we can start to give it values. So this is line 32. Moving down here to the line 34, we start to see that idea I was discussing. So inside of node is a pointer next to another, to a possible another node. So we see right here, line 34, demo.next is equal to a new node. So we're saying, okay, this is next. Next is equal to a new node. Go ahead and create a new node and link it, point it back. So the pointer next points to a new node. So we can start to create a chaining structure of one thing pointing to another thing, pointing to another thing, pointing to another thing. And this allows us, this very basic idea, allows us to create some very complex data structures within C++. But this just introduces it right here. Using these, though, we can build some very complex things. So, returning to this, we have our blueprint for our structure, lines 23 to 27. We created a new variable demo based on this data type we've defined. Inside of that, its data we gave to 5, and its pointer next we set to a new node. Now, we can use part of C++'s functionality to point to where that address is to get the value that's at that location. So previously, up here at the top, we were just looking at the addresses and we weren't doing anything with them. We were just storing them. Now we're saying, okay, go to that address and now get that value. We do this using the hyphen and greater than sign. That is a pointer. So we're saying, okay, for demo.next, right here, which we know because line 34 is set to a new node, whatever it points to, it's pointing to a new node, get its data and set it to 6. So we can start at demo, we can then go set next equal to a new node, and we can go from demo to this new node and say, okay, for whatever it's pointing to, this new node, get its data, which is right here on line 36. So the node next is pointing to also has data, and its data is now equal to 6. So let me run this again. I'll move this over. clear this and run this. So we see the value of the first demo is 6, and the value of the second, or the value of the demo is 5, the value of the second is 6. So this is a complex idea of using pointers. Again, let's review all of this. At the top, we saw we can use the ampersand next to a variable to get its address. Where is this value at? We can save this address using a pointer. A pointer is a special type of variable that starts with an asterisk in front of it. It also has a data type, so this is the type of data it's pointing to. Again, C++ is a strongly typed programming language. We always care what the data type is. So we can get its address. We can store its address using a special type of variable called a pointer that all of it stores is the location. Then we can start do stuff with that location by defining a new structure using a blueprint for a structure right here using the keyword struct. We then can use pointers to point at new things. So we can create a variable, we can give it data, then we can set its pointer to a new type of that data. Then we can set the thing it's pointing to's data to something. So we can move along a chain of different things that point one to another, to another, to another, and build our own data structures using pointers. This is a very powerful concept, as I talked about. And we saw we can get that data by going to next using hyphen greater than whatever it's pointing to, so not the address now, but the value that's at that address, and then we can do things with it, change it, or get it back. And then as we saw when we ran all of this, we can get an address, we can save an address, we can create a new data type using the struct keyword, and we can then point at a new thing of that data type using pointers. Thanks for watching.